we'll practice the ones and the zeros on the second one, but I would obviously strongly recommend the shortcut. That's a shortcut for a reason, right? So if I do that, I multiply this way. I would do -3 times 1 minus 2 times -2. And I get -3 minus a negative, so that becomes +4. And my determinant is 1. So it would be 1 over 1. And then we switch the A and the D, so the -3 and the 1 switch locations, and we change the signs on the 2's. This becomes positive, this becomes negative. And so if I multiply in that 1, it actually stays the way that it is. This would be the inverse to A. Good on that one? Yeah. Okay, then one, right? So now we've got a 3 by 3, and we have to do the pattern 1, 0, 0, 0, 1, 0, 0, 0, 1. So I want to fill that pattern. There's already the 1 in the top left, so we're going to work our way down. Now, you may have done it differently than me, so don't freak out if you don't follow exactly like we did. But I'm just going to work it out, and then at the end, it should be the same no matter what you did. So in order to get a 0 where that 3 is, I would do -3 row 1 plus row 2. Or you could do 3 times row 3. So out of curiosity, how many of you used row 1? How many of you used row 3? Okay, so let me do that one then. So 3 row 3 plus row 2. -3, -12, -21, 0, 0, 3, 3, 7, 9, 0, 1, 0, 0, -5, -12. And that takes the place of row 1. No, row 2, sorry. Okay, now I want to get a 0 where the -1 is, so I can just add row 1 and row 3. Then I need a 1 here, I need a 0 there, okay? And I need a 0 here, here, and here. All those places are where I need the zeros. So you have options. You can either multiply by a fifth to get the 1, but then you're dealing with a fraction, or you can work with that -2. So if I want to cancel out this -2, I have to use row 2. I can't use row 1 because I'll lose the 0. So I can do -1 or -2 row 2 plus 5 row 3. So the -2 on this one does that, and then the 5 on the bottom I get 0, 0, -1, 5, -2, -1. And I'm actually going to just multiply by -1 right now to get rid of the negative. And now my bottom row is good. So I got to work with the zeros on the way up. So if I want a 0 where that 12 is, I can multiply row 3 times 12. And add it to row 2. And then I can even do the 1/5 now, the -1/5, to make that a 1. I need a 0 here and here. So for the first one, for this one, I have to use row 3. Okay, so we're going to do -2 row 3 plus row 1. -2, 0, 0. And then the last 0 is here, -2, row 2, row 1. And then the right side of this is my inverse. So -13, 6, 4, 12, -5, -3, -5, 2, and 1 should be your inverse. Questions? All right, so we're gonna finish and then I'll jump back to the homework question. Okay, no, sorry, 7-7, which is the determinant of the square matrix. You already know how to do half of this because we did it last week, right? The Jesus fish is the square matrix for a 2x2. Is the determinant for a 2x2. And then we're gonna learn how to do one for a 3x3. These are not difficult by any means, but the 3x3 gets super tedious, okay? So you have to be really careful. It's a lot of multiplying, and then adding at the end. So you just gotta be really, really careful, okay? And then you'll see the application of this in tomorrow's lesson, not tomorrow, the day after, because tomorrow is Ash Wednesday, so we're on a shortened schedule. You'll see how we apply it. So first of all, this is what we did the other day, the determinant of a 2x2. Remember that you multiply the curve, like so if I start on the bottom left and work my, or bottom right and work my way up, I'm gonna multiply these two together and then I'm gonna subtract from it the product of those two. And I get a single number, and that's the determinant of a 2x2. So again, this is like that Jesus fish, right? So it says evaluate the determinant of each of the following matrices. We literally just multiply these two and then subtract from it the product of those. So 1 times -2 minus 5 times 3, and I get -2 minus 15, which is -17. Same thing for B, multiply these two first, so -1 times -3, minus, and multiply these two, 4 times 2, 3 minus 8, and I get -5. Biggest mistake people make here is adding their products instead of subtracting, so just be really careful. Remember that the I on the fish reminds you to subtract them, okay? Silly mistakes get made here with like positive and negative numbers, that kind of stuff. And this won't flat out be like a test question, but you're gonna see we use this in 7-8, so you'll see why you need it when we get there. All right, so minors and cofactors we're actually gonna skip. Just pretend it's not happening. Skipping, because you can use minors and cofactors to skipping. Sure. You can use minors and cofactors to find the determinant of a 3x3, but I'm going to teach you a different method that I think is easier, okay? I have usually taught both in the past, and nobody ever picks the first one, so why the heck would I teach it to you? If you want to, look it up. You can find how to find the 3x3, or determinant of a 3x3, by using, these are called like minors and cofactors. So we're not going to do this. We're not going to do this. We're going to go here and I'm going to teach you a different method. So I'm all the way at example 5. Yeah. Oh wait, hang on, my volume is really, really soft. Go ahead. You sure can. All right, so I could write this out and I think it's so much easier just to show you, okay? But realize that this is not the method that we're just on this last slide. This is a different method. So this is a 3x3. We see that, right? There's 3 columns, 3 rows, okay? It has to be a square matrix, which means the same number of rows, same number of columns. For a 2x2, we do the little fish thing. For a 3x3, the first thing you're going to do is rewrite the first 2 columns to the right-hand side. So I'm rewriting -2, 1, 3, 1, -1, 1. And I'm making sure to do that so very carefully because if you mess up one of those signs, you're already wrong. So we rewrote column 1 and 2 to the right-hand side. So now I'm going to multiply along these diagonals. This one, and this one. So I'm finding the product of the three numbers in each of those diagonals. So I'm going to do -2 times -1, that's 2, times 0, that's 0. I'm going to multiply the next diagonal, 1 times -2 times 3, that's -6. I'm going to multiply down the next diagonal, and this is when you really like the zeros, because it's 0. And then I add those three numbers together. So I go top, left, bottom, right first, just like the Jesus fish. Think we go that way, right? And then we come back and we go the other way. So now I'm going to multiply these three diagonals. 0 times -1 is 0 times 3 is still 0. -2 times -2 is 4 times 1 is 4. And 1 times 1 times 0 is 0. Add those together and I get 4. And I do the top left, bottom right sum first. So -6 minus the top right, bottom left, 4. So just like with the fish, we subtract them in the end. And the order there is obviously important if you switch the order the sign switches. This answer should be -10. Now we're going to get out our graphing utilities because I'm going to show you how to check this. Okay, I'm going to go to my matrix menu, second matrix. I'm going to go over to where it says edit. I'm going to pick that first one because I don't need anything that's in there anymore. And I'm going to make it a 3 by 3. And then I'm going to enter in my original matrix. So -2, 1, 0, 1, -1, -2, 3, 1, 0. So I entered in my 3 by 3, not the ones I wrote the columns to the right of it, the original matrix. Good so far? I'm going to say second quit and get back to your home screen. And I'm going back to that matrix menu. Second, matrix, and this time I'm going to math. What's the very first thing you see? Det, which is determinant. You hit that. We want to find the determinant of matrix A. Second, matrix, now we go to the names one. A, enter, and there's your determinant. So again, you're not using a graphing utility on your test because that took a lot less work than the other way. And I'm going to force you to do the work. Again, all that work has to be shown. So I warned you a lot for the last test, but I'm going to keep doing it. I'm going to give you the answer sheet. If your work is not here and you magically have the number -10 there, those points are going to magically disappear. I show you this for two reasons. One, obviously, if you get frustrated on homework, I want you to be able to check your answer. But also, on Friday, like tomorrow, Thursday, I'm going to show you how to use this to solve a system, because that's what Kramer's rule is. And then on Friday, what I'm going to do is assign to you like an optional quiz video. So you'll get a problem. You'll have a certain amount of like 45 minutes to complete the video doing that problem. And I encourage you to check your answer before you do it, okay? But I'll explain that a little bit more towards the end of the week. But that is one of the reasons why it's very helpful to have that graphing utility to help you. writing it out. All right, you do this one. Okay, so again, evaluate the determinant by hand, and then you can check it on your calculator. Sophia, the calculator part or the actual is duplicate those first two columns, -2, 3, -1, 1, 0, 2. And then you're going to multiply down, top left to bottom right, add those together, and then multiply down, top right, bottom left, add those together, and then do the first minus the second. So I'll let everybody work it out a little bit, and then I'll go over that. All right, so if we multiply down the pink diagonals first, this is 0. 1 times 1 times -1 minus 1. 3 times 3 is 9 times 2 is 18, and I get positive 17. And then multiply down that purple diagonal, so 3 times 0 times -1 is 0. -2 times 1, -2 times 2, -4. And then 1 times 3 times 3 is 9. Those you get 5. And then we want to do the 17 minus the 5. Again, the order there is important, and you should get a positive 12. Easy stuff, right? So today's really like laying the foundation, because when we get into we're going to learn how to solve a system using this stuff. You'll do it 4 times for every, like if it's a 3 variable one, you're going to end up doing the 3 by 3 determinant 4 times. Okay? If it's a 2 variable, you're going to do it 3 times. And but that's the last section. There's 3 things that we're going to use application of determinant in there, but that's one of them. Okay? So that's it. It should be super easy. Tonight's lesson is brief. Let me actually make sure I assigned it. I scheduled it on WebAssign. And then I'll go back to that question from homework.